come to our actual slides, right? So yesterday we discussed, right, what is machine drawing. So we also seen what is engineering drawing, because we already done the course, right? Engineering drawing is all about visualization. Okay, it's not exactly as engineering drawing as it named. Okay, because what you study in the first year, right? It is about visualization and enhance your skills. Okay, of the like imagination, visualization to right to understand by based upon the description, right? It gives you a different skill. Okay, so machine drawing is more about the components. The actual assembly is there, right? Or you're designing some component which you have to write convert into drawing, so which can be manufactured. Okay. So that is for this machine drawing. Okay. So what you see here, right? I think now on the screen, I think now you're able to see this one. Okay. That is actually right. Machine drawing. You observe carefully. So in engineering drawing, right, you might have drawn a similar figure, but actually you might have not represented right this section. You see x-axis is there, right here. So in engineering drawing, you might have drawn orthographic projection, but you don't draw this sectioning there. Okay. So there, right, you want to show internal parts also, right? Then you make cross section and see. So wherever is cutting is there, you are seeing this slash like this hash, right? We will be studying these things separately, right? What direction to keep and how to change those things and all those things. Okay. Where a hollow is there, we don't make the hash. That is one difference. Other difference, you're writing this, right, like this. Holes, 3 holes, dia 6, equispace, SP. Generally in engineering drawing, you don't draw these things. Only just you keep the dimensions. But here, right, you will be adding other any features, fillets, any chamfer is compulsory, functional requirement is there, then you represent those things. Okay. So there is a main difference between engineering drawing and machine drawing, right? It means especially you're drawing the orthographic projection. So I'm talking about only orthographic projection. Okay. So here also, right, we draw everything in first angle projection. Okay. So I don't explain again what is first angle projection. Maybe I'll show some slides, but you explore yourself, right? What is first angle projection? Okay, don't have any confusion on the first angle projection. So, and you see here the dimension is that 25 mm, 525. Okay, so why we call this a machine drawing, not production drawing, right? The main difference is, as one of your friend mentioned, right? You see this 75. So no component size can be produced exactly to the value. Always you have to give some deviation. Okay, that we call it a tolerance. Tolerance means allowable deviation on a given size. Okay, size is nothing but dimension. Okay, what is allowed? Variation is allowed. That is tolerance. Okay. See, I think if you are posting messages, I cannot see message while sharing the slides. So if you want to ask something directly, you can ask. Or you want to respond directly, you can unmute yourself and you can ask question. Or you can, yes, yeah. Okay, so that is next class only I will see. Okay, so don't disturb now. Okay, it is fine actually. Okay, fine. Yes, yeah.
Hello, sir.
Yeah.
Sir, the diameter of that dotted circle, how to detect that?
No, don't bother about this. This is just for explaining only machine drawing. Don't go in details because I have not seen also. Okay. So this picture, right, first which I'm showing on the first slide, there's only to tell you what is the machine drawing. Okay. Don't go into the details. I don't know whether they're accurate or not. Okay. So because all those things we're going to study, right, during the course of learning machine drawing, right, we'll be studying. Okay. So only thing is you should understand what is the main difference between machine drawing and production drawing. And machine drawing, right, and one more thing, it's the final stage, means the actual component, how it looks like, that is the machine drawing. I told that yesterday. Production drawing means is little different, right? Suppose a component is manufactured in 10 stages. Suppose you see this component. Okay. So actual component which you take may be like this initially. It's a block. Okay, size like so. I think that I don't have space. That's why I'm drawing this side. Okay. So it's a simple block you take like this. I think it's a maybe bigger block. Let me erase it. So a circle. So initial block like this. So you have to make that block. Okay, that's the first stage. Okay. So diameter may be 75, right? Suppose they're producing by casting. Then just they mention it is 76 plus or minus 0.5 mm. Okay, so they don't mention in microns, so it's because the casting they produce width also this much. Like suppose width is 40 mm, they produce 41 mm or something. Okay. Otherwise, tolerances will be in terms of microns. On the component side, it's a close at the final stage. Tolerances will be very very close. So it depends upon the again functional requirement: 20 microns, 10 microns, 2 microns. Okay, 50 microns. But initially at the casting stage, we don't bother about much dimensions, but you'll be making bigger size. We always you can reduce the size of the block, raw material or ingot, whatever it is. Okay. So once you produce like this, right? First stage, second stage, what you have to do? Suppose you see here. So there is a block like this is there, right? So you have to remove material on turning operation, right? And then your block look like this. Second stage, it looks like this. And you will be having some circle like this. That is the second stage. Again, you will be having all the tolerances on this one. What is the whole size it has to be produced? Okay. So all the things inside also you will be having a hole like this. Okay. So that is the second stage. So that is the production drawing. Okay. So machine drawing that we will not have at different stages. What is the final component, how it looks like? That is the machine drawing. Okay. So production drawings are always associated with the process planning sheets also. Means how to produce the component from the previous stage to next stage. Okay. So we already discussed this one. So engineering drawing, right? So orthographic projections. Okay, we say machine drawing. Machine drawing means more about these are part drawings. So there also orthographic projections only we do, but it is as per the design. Okay. So someone's designed the component, right? Based upon that, we'll be producing the drawings. Okay. In assembly drawings, so all the parts together, you assemble them. Then you draw the drawing overall assembly drawing you draw. Part drawings means it is individual components you draw separately because while manufacturing, you will be manufacturing part wise only. You cannot manufacture whole assembly, right? You have to manufacture part wise only. So part drawings are different. So assembly drawing purpose is to understand how to fit them. That is one thing. Okay, which component comes there. Okay, another advantage is there of the assembly drawing. Can someone tell me why the assembly drawings are very important? Anyone just tell me why assembly drawings are important? Okay, so I will tell you. Okay, so assembly drawings, right? There you see, right, which component is mating with which component. Okay, so which is fitting over the another component. So what type of fit they should have? Whether we have threads to fit them, because the assembly means what you have to fit somehow, right? So just is a clearance fit or just is a push fit, transition fit, fits actually. Means how you assemble them together. Okay, you're using a nut and bolt. Okay, or you're doing a welding or you're doing what it is. Okay, so that you will get from the assembly. So movement of the components. Again, there is a functionality that information has to be given separately. Okay, so designer has to give those information. Okay, means shaft has to run on the bearings or shaft has to run on the journal. Okay, or shaft has to be fit tightly without rotation. Means some keys has to be provided, key holes are there. So all those things, if keys are there, means what type of keys are required or how much resistance the key has to show. Okay, so all the things said will come there in the assembly drawing. Okay, so right, you will understand. So it is a very complex one. Once machine drawing is there, up to part drawings it is okay, but once you assemble them, right, then you have to define the fits. Okay. So you can fits also, so many varieties of fits are there. As clearance fit is there, transition fit is there, or interference fit is there. Okay. Suppose see, right, those things that you understand while going. During the induction program also, right? I think this is the induction class. Right? I'll be showing some pictures so that you'll be getting an overall idea. Okay. So that is about assembly drawing. So production drawing, right, we have seen that already. I explained you. It's the same as part drawings, but actually stage-wise details. Okay. So in machine drawing, you will be having only one drawing, but based upon the one drawing, right, to produce, how to reach that shape, right? You are making the component different stages. The stage-wise drawing you have to make, and you have to give all the data. What type of tolerances required at that stage? Okay, what type of finish is required, as your friend mentioned, right? What type of finish is required on the surface? Okay. See, at the initial stages, right, we don't bother about the finish. Okay, whatever is as produced casting, as rough turning, that is fine. As drilled, it is fine. So we don't go for finishing operations like grinding, reaming at the early stages, because so grinding, reaming, or boring operations, right? Those things are required to get the close tolerances, generally which is required at the final stage. Okay. At the initial stages, you produce the components by forging, casting, and even rough turning. Okay. So you are going to the final stage, then you use more precise machines, and you use more close tolerances, try to achieve close tolerances. You choose process also in such a way that you can achieve the close tolerances. Okay. Suppose drilling is there, it cannot produce a close tolerances. You have to go for boring operation or reaming operation, depends upon the size of the hole. Suppose you want to produce cylindrical surface, at the initial stage, it is okay to produce using rough turning. Okay. Suppose at the end, if you want to turn and you want to have a very good finish, then you have to go for the finish turning. If the material is soft, if the material is so hard, then you have to go for grinding. Because most of the engineering components, right, just before the final stages or in between, they'll be going for the heat treatment also. The initial stages, right, the material is in annealed condition, right? You will not have that many properties. You might have studied in metallurgy, right? And initially we don't do heat treatment. Why? Because machining is going to be very complex. So you are going to remove the most of the required material. Okay. So then you heat treatment to increase the hardness, strength. So then you go for finish process like hard turning, grinding operation. Okay. Any other polishing operations. Okay. Okay, so right, that is also right. As a production planner, right, you should know when to go for heat treatment, because the moment you do heat treatment, it will put a lot of limitations on the manufacturing process that you can use. Okay, the moment you do heat treatment, enhance the hardness to 45 HRC, 50 HRC, right, you cannot use any of the drilling process and all those things. Okay, only maximum you can do is hard turning, and you can do the grinding operation. Okay, so these are the things, right, you should know to make the production drawing, because heat treatment also comes in production drawing only. You have to mention at what stage you have to do the heat treatment. Okay. Yeah, that is about the production drawing. So what you see here right now in the screen, that is a production drawing. Okay. So the main difference which you see from the machine drawing and production drawing, right, you'll be seeing the tolerances on the dimension. So we call as so metrology subject is over for you, or yet to be covered? Engineering metrology. Any one of you respond? Engineering metrology, is it completed, or you are going to study that course?
Yes, sir, we have completed the third semester.
Third semester, metrology. Metallurgy, I'm not talking about metallurgy.
Okay,
Metrology. Metrology.
No, sir.
Okay, fine. Yeah, because the third semester I got doubt. The third semester cannot be covered. Okay. So see, what you see here, right, that 75 plus or minus 0.5, it mentioned, right? I mean, there is allowable deviation on the given size. As the outside diameter, right, is just maybe flange. So we don't bother much about the outside diameter. So they give a huge tolerances, plus or minus 0.5. Means almost is a 0.5 mm is a very huge tolerance. So you can produce using any sample rough turning, you will be able to produce. You see somewhere they given internal diameter. Internal diameter, I think if it is a critical. Okay. Yeah, here you see. I think internal diameter is given here. Right side. 20 diameter, it is given 0 to 0.15 mm. So it is right 150 micrometer. Still, it is a big tolerance. You can produce by just simple operations. But only the thing is difficult, right? They mentioned it is a geometrical tolerance. So you're going to study these things in metrology very detailed, but anyhow, like we are also going to discuss at the end, right? I'll try to discuss because you're not exposed to this one. Okay. So, right, what you see here, right, what I'm showing here, there's a concentricity. Okay. So we also give in production drawing not only the dimensional tolerances, we'll be giving the geometrical tolerance also. Please remember. So we have two types of tolerances, dimensional tolerances. Okay. It's nothing but on any given dimension length, linear length. Okay. Linear dimensions, right? You give some tolerance, there is a dimensional tolerances or angle you can give. Okay. There is also dimensional tolerance. Okay. Another part, right, which are more complex. Okay, and if you define those things, your cost of the product increases like anything. Okay, those are nothing but geometric tolerances. Geometric tolerances means is about cylindricity, circularity. Okay, just you listen. That's it. Okay, no, don't worry whether what it is. Perpendicularity. Those two surfaces are there. How much close they have to be perpendicular. Okay. So our concentricity, our parallelism, you see this is what you see here, it is a parallelism. What you see here, it is a perpendicularity. Okay. You see this triangle is there, right? There is a roughness, as one of your friends mentioned, right? There is a roughness. Okay, it's a roughness, 6.3 micrometers, 1.6 micrometers, 3.2 micrometers. Okay. So that tells, right, what process has to be used, because if you use a simple turning, you will not be able to produce 1.6 micrometers roughness. Okay, you have to use some grinding operation. Okay, that way, that same thing. Inside here, they kept 3.2 mm of the hole, right? I think I will show you. I will arrange it. Sorry, it got hanged. Wait a minute. Yeah, you see here. So 3.2 micrometers. So you should check actually, right, whether with drilling you are able to produce this 3.2 micrometers or not. So all this data you give in the production drawing. It makes the production drawing more complex and more detailed. And you believe me, right? These details will control the cost of the component. So these production designers, right? They paid very hugely. Why? Because, right? They only can decide how, at low cost they can produce the component without compromising on the functionality. See, functionality, they know, okay, what quality of the product they have to achieve. Okay. Further, they have to give the optimum, these tolerances. Closer to the tolerances, the part of the cost of the component is going to increase. So cost of the assembly is going to increase. Cost of the product is going to increase. Okay. So they try to give, right, as maximum tolerance as possible without deviating from the functional requirements of the assembly or quality requirement of the assembly. They decide what cost they can produce the component. So it depends upon that one, they plan how close they have to go the tolerances. Okay, this is assembly drawing. Okay, still we don't call it the assembly drawing. I am showing it. Okay, so you will understand exactly right at the time, because just here only you understand that where the components is being placed. But it has to be provided fits also. Suppose it is there, right, bolt, and it is going inside. So whatever fit it has to be there. As there are no many components, they are not given fits. I think here is not required to define the fits because just use a bolt joint. Okay, otherwise, right, assembly drawing means you will understand there. You have to define the fits also. What type of movement should be there between different components. So we call it as elements also. Different elements, right? Parts, different parts, what type of motion should be there. And you'll be having assembly drawing means and part table also. How many parts are there? Counting 1, 2, 3, 4, right? How many parts are there and what are the names? All those data will be there in the assembly drawing. So that will be, right, taken care by Nistana sir after the mid-semester examination. Okay, so this is the overall syllabus actually. So like you, whatever is the syllabus copy you have seen, right? There is actually, right, as an overall content, but here just I divide into some sections. Okay. So we cover in the same order. Okay. So basic conventions. Okay. So you might have got exposed to some conventions during your engineering drawing. Okay. So you know, right, different lines for what purpose we use. Okay. All that things. And machine drawing will be a little bit more. Okay. Going to come into picture. Okay. So how to represent the holes and all those things you're not studied there, right? Here we'll be studying those things. Okay. So how to make some later lines. Okay. So we're not stressed those things there. Here, right, you have to make those things very clear. Okay. So how to represent the radius, how to represent the fillet, okay, and even number of lines which you use here also more. Okay. So there in in engineering drawing you'll be using very few lines, thick line, thin line, and double dash lines. Okay, or dash for axis representation, for locus representation. That's it. Here, right, you'll be having more number of lines which has to be used in the machine product. Okay. So we'll be studying orthogonal projections. So there's going to be a first sheet. Okay, I think I clubbed this orthogonal projections and sectional views both together is only one sheet. Okay, so it's not separate actually. Okay. So only sectional views you're going to, right at the time we will discuss what exactly they are. Okay, I'm not going to stress on those things. So you'll be studying about screwed fasteners. These are standard elements. Okay, these are the standard elements. Okay. Right, and it is actually right, mostly you can even get this data even from the design data book also. If you see design data book, right, while designing, they don't mention, right, just only something they mention M6. Okay, different types of fasteners are there. Okay, I didn't remember those names, but they'll be giving only some designation where you should be able to draw those things. Actually, right, fortunately nowadays you have the computer, right, where in the AutoCAD and all those things, right, you're having already inbuilt libraries where you can pick these fasteners. But it is important for you to draw these things on the drawing sheet to understand those features, how they're different from each other. Okay. You may think that, right, we're not going to draw these things never, but no, don't think like that, because it is very, very important to draw these things. Even if it is AutoCAD, use also, right, I insist to draw with hand only so that you will understand the features and the differences, right, in those things so that you can feel the component. Okay, if you're using AutoCAD or some softwares, right, just you have to pick those things from the elements from the standard assemblies, standard library, right? You will not be able to know what exactly it is, just you are going to use them. So again, right, some different joints also, key, quarter, and pin joints, right, you'll be studying. Okay. So, and shaft couplings, two shafts are there, how to couple them, right? The coupling configuration, right? So that elements also we are going to discuss. We don't discuss much, you only have to draw. Okay, so there's no much to discussion. Okay, but wherever is something is there important where you do common mistakes, that I'll be pointing out those things. And again, different types of joints, how to represent them, riveted and well jointed. Again, while drawing here, you understand, right, how many varieties of riveted joints are there, I mean, how many types of rivets are there. Okay, so what is the minute details in those rivets. Okay, and configuration. Okay, how to make a tough rivet joint, how to make different types of welded joints, symbols especially, right? We don't do much about weld joints, but actually you're going to study mainly about the symbols for different weld joints. So you understand, like, suppose till now you may know it is only just lap joint, butt joint, but here, right, you'll be seeing so many varieties of types of joints, okay, which people use in the structural applications, bearings and gates. Okay. So again, mostly, right, we'll be discussing about, right, about standard representation drawing, means because we cannot draw the complete gear. Okay, just only we represent with some convention. Okay, so those things, bearings also same. Okay, how to represent them. Okay, so then, right, as we not covered this limits, fits, tolerances in the metrology, right, is not over. So because for production drawing, these things are required. Okay, limits, fits, tolerance. So I'm going to discuss those things. Okay, so this is more of theoretical. This too is more of theoretical, less of drawing. Okay, so above you have to draw, right, many things, many elements you have to draw. And this part before mid-examination, I'll try to cover. Okay, surface roughness, if I'm not able to cover before mid-examination, I'll cover after the mid-semester examination. So because these topics may or may not cover during your metrology also up to what depth. So I'll be discussing with respect to the production drawing requirement, whatever is required for the production drawing, that I'll be covering in this limits fits tolerances, so that you get some clear idea. And at the end, Nistana sir, right, will teach these things. So mostly teaches assembly drawing, part drawings. Okay, production drawing he may stress less actually, because that's not part of the machine drawing. Okay, as we don't have separate course on production drawing, right? So we included here as the last topic. Okay, which he may club with this assembly drawing and he may discuss those things. Okay. But right, production drawings are entirely different, and different books are available, and it's a different subject at all. Okay, but because of right, I don't know. It is not there in our regular curriculum. Okay. So, but you try to explore this production drawing also. Given sir is not covering much, right? Because if you want to go to a core industry, right, what is required is production drawing. Okay. See, drawing wise, you don't see any difference. But right, it is more about the manufacturing process to selecting the manufacturing process. It depends upon the stage. It depends upon the tolerances on the drawings. Okay, so you have to divide neatly into number of stages also, and also it's not depends upon only you, and also what type of shop floor layout you have in the industry. Okay, so what is the capability of the machine? So the process planner, right, is a very important key person, right? He should have complete idea on the shop floor, and he should know what is the equipment available in the shop floor. Okay, and what is the capability of each machine, and how close tolerances it can produce each machine. Okay, so how effectively, see again, I told that why they are paid very hugely, right? They decide, they enhance the utilization of the equipment. Okay, they reduce the scrap of the components. Okay, they minimize the number of the process. Okay, even they are the key persons to control the cost of the actual product. So maybe actually it will not be done by one person, it is done by team. Okay. But if you as a one person, individual person is having so much capability, right, then like it's going to be very good. Okay. So don't see this side. Okay. So these are the typical drawings which you are going to draw. Just for that I have shown. Okay. So otherwise we are going to see those things again at later stage also. Okay. So see, I told that one. This one you have when you put the assembly, right? You're going to draw this bill of materials. Bill of materials means part 1, part 2, part 3, whatever parts you have. How many parts you have also. Is the assembly, right? It's not assembly drawing actually. It's a joint. Okay. But still, as the number of parts are more, you're going to, because you're joining the two shafts using some method. Okay. They're mentioning it is sleeve. It is made of mild steel 1. Rods you have mild steel 2, and even quarter that is made up of steel. Steel means just alloy steel. That's what he mentioned. Mild steel, and they have quarters too. Okay. So those things we discuss when it comes. So these are the quarters, what you see, right? So there is shearing, so they need to have high strength. Okay. So that's why they mention steel is some alloy steel after heat treatment it's getting enough strength. So this is the shearing. So joining the two shafts. Okay, so that is about this one. Okay. So right, we'll be studying about these conventions. Just for your idea, I'm showing those things. Okay. So mostly you'll be using this arrowhead everywhere. Okay. So everyone, please don't draw any other arrowheads. Even in the books or convention, they may show different indications to represent arrow, right? Single lines, double line, or whatever it is. So this is also one type of thing. Don't use any of those things. Use only the one arrowhead, which is filled arrowhead. Okay, please use only this one, filled arrowhead. So I told, right, conventions we study. Suppose a spline shaft is there, no need to draw everything. Just you show this. See this convention. No need to draw this one. Just a convention you have to draw. Okay. So and also how different it is, right? So you're seeing here, right? Sectioning you're showing. And you're drawing this indication also. This is very important in machine drawing. Okay, even production drawing also, these things are very important. Okay. You have to write clearly. Okay, no, we don't keep the dimensions, just we write dia 25, deep 25. Okay. So you're not mentioned deep means they just go for blind hole. So through hole, not blind hole. It's a through hole. Okay. If you're defining dimension means it is only there, then they go up to the depth. So again, right, if they have some, I don't know whether you know what is CS, this is a countersink. Okay, CSK. So we're going to study these things also. Okay. Suppose you're using some screw with some head, right, it has to go inside, it should not appear outside. Then they go for this type of chamfering, edge chamfering inside the hole. You see here, they mention holes, then it is C bore means is the counter bore. So this will machine drawing, right, when we are studying those things, right, pay attention, those things. So I am telling, right, so you don't know what is C bore, then you cannot understand the drawing. Okay. So, right, you have to understand that, not actually what happens, right, many students just they write C bore and then they write, they draw the drawing and they submit it. But that's of no use to you. Okay. So if you want to read a drawing in future, you should know what it is. C bore means it is a counter bore. Okay. CSK means it is what is this, counter sunk. Okay. So, right, those things you should know. Okay. So here also you see what is dia 12, dia 15. So these things, right, we will be discussing those things. Okay, during our syllabus. Okay. So this is we also write use this is orthographic projection, nothing but it's a sectional drawing. Mostly we do the sectional drawing. In engineering drawing, we have drawn simple drawing. Right here, you will be doing sectional drawing. You see, there is a front view, top view, and right hand side view. Okay, so they draw the section to show some features. So, and machine drawing, mostly you have to represent the radius, diameter very clearly, symbolic. Okay, where we don't do in orthographic projections in engineering drawing. Here, you have to be very much specific about those things. Okay, and bottom side, what you see are threads, different types of threads. Okay, while drawing, you will feel those things. Okay, it may take a lot of time. You may think that why I am drawing these things, but don't feel like that, because that will make you to remember. Okay, these are the different types of threads that are available. Okay, means while designing, you have to choose the thread also carefully, because every thread is having different application. Okay, so even bolts also, right? So many varieties of bolts are there. Okay, so otherwise you don't feel the difference. While drawing only you understand. Somewhere it is shank is diameter is less, core diameter is more, or head sizes are different. You see hexagonal are there, square are there, and so many. You are having this hexagonal socket inside. Okay, so many varieties of bolts. And while drawing, you understand, and if it, nuts, different types of nuts. Even though you might have seen, right? Even you just for you, if you are thinking nut, right, only one nut comes into mind. But you have a different types of nuts, and you have to choose carefully while designing. Depends upon the application. Okay, again, riveting joints. I told, right, rivets. Okay, so huge number of configurations are there. You're designing a boiler. Okay. If you think that, okay, just I put a lap joint and put some rivets, it is over. No, it's not like that. Okay. So, right, it depends upon the strength requirement. You may do in design, but you may have not drawn actually. So, you don't pay much attention, but here you're going to pay good attention. Okay. So, this is about these things. So, these things we study in detail. Just I'm telling you those things, what I'm studying. And also, right, I'm going to cover about the fits, limits, fits, tolerances. Right? These are about these aspects. Okay, so now you may not be able to understand what it is, but there will be very clearly understanding what exactly, why we're representing hole like this, why we're representing shaft like this. Okay, what exactly they mean, and what is this basic size, what is this line, zero line. Okay, so he's mentioned zero line, right? So all those things we are going to learn. What is clearance fit, and what is interference fit, what is transition fit. So those things. It's the last topic which I cover, right? I'm not giving induction for other things, but what last topic which we cover is roughness. Surface roughness. Okay. Surface roughness is very, very important aspect because it defines which manufacturing process to use. Okay. You see the roughness variations or two use variations are there, right? So the moment you keep some symbol, okay, so it changes completely the manufacturing process. Okay. So with this slide, I stop here. Okay. And I will share these slides with you. Everyone, please go through these slides. Okay. And if you have any questions, you can stay back and ask. Otherwise, you can leave the meeting.